Hello, my dear students and the rest of the learners. Welcome to part 20 of a 7-part series of tutorials or presentations in computer structured programming in C and Pascal. This is section 3 of 4 in the topic subprograms. My name is MemJM, or you can simply call me EMELISWAP. In this tutorial, I'm going to look at how we implement subprograms and parameters in C and Pascal. This is a follow-up to part 18 and 19 in this series. And therefore, after having gone through part 18 and part 19, this part 20 illustrates how to implement what you have learned in form of subprograms or in programs using C and Pascal. So in this presentation, I'm going to demonstrate sample programs in C and Pascal, implementing subprograms, variable scopes, and parameters. The following are sample programs in C and in Pascal, implementing subprograms, variable scopes, and parameter passing. We begin with a program for implementing subprograms and parameter passing. It prompts the user for his or her name, welcomes the user, requests him or her to enter any radius of a circle, and then it computes area and perimeter and displays the area and perimeter of the circle on the screen. So this is our C program. The comment is program implementing subprograms and the parameter passing in C language. Then we have #include stdio.h. We said in my previous presentations that we include this header file because it contains functions that we are supposed to use for performing input and output operations. And then we declare a memory location that is going to hold a value that will not be changing, and that value is going to be a value with fractional part or decimal point. And then we assign into that memory location that we are calling pi the value 3.142. So because this value or this memory location is being declared outside of any functions or outside of any subprograms, then its content is accessible across the entire program by all the subprograms, and therefore this one becomes a global variable. Its content is accessible across. In fact, the best one for it is global constant. And then we have our first procedure. This is a function, void function. Remember, procedures are called void functions in C. We said that these receive values. They can receive parameters, but they don't return any value. And therefore, because of that, because there's no return value, we have them as void. So in this case, I have a function called void input name. So I have a function that will not return any value. It is called input name. So this is a void function without any parameters. There's nothing in between the parentheses. So what is it supposed to do? So inside it, we have what we call local variable. So the first local variable is of type character, and it is going to hold or accommodate a string. And this string or array of characters do not exceed 20. And then the function or the void function is having a statement that requests the user to enter his or her name and then read the name entered next line. So enter your name. Then the next statement indicates or allows the processor to read the name entered. So get name. And then it displays the message on the screen, welcome, welcome. And then it displays the name or the content of memory location called name on the screen. So picks what is the memory location called name and displays it on the screen. So the user will see a statement like, if, for example, when requested to enter the name, the user entered Julius, then the program or this function will display on the screen, welcome, Julius, welcome, Julius. Julius being the content of the memory location called, or in the memory location called name. So the put function or the put statement picks what is in the memory called name and displays it on the screen. And that is the end of that function. So this void function is only performing a single task, requesting the user to enter his or her name and displaying his or her name accompanied by the name or by the text welcome. So that function in Pascal would be called a procedure, but in C, we call it a void function. Now, this void function, this function here has one local variable. This local variable is name. So this variable, the content of this variable cannot be accessed by other functions. It's only accessible within the input name function, the input name void function. But the global variable up there, or the global constant, which I called pi, because it has been declared and initialized before, functions, void and non-void functions, then the content of that memory location called pi is accessible, can be accessed by any program. And therefore, if any function within this program makes any change or assigns a different value into that global variable called pi, the content will change. The next function, the next non-void function is called input radius. So this is a function. It's non-void function without parameters. So the name of this function is input radius. Input radius. And it returns a value which is of type double. So this function is not receiving parameters from outside. It's not receiving arguments from outside, nothing which is being passed to it. But itself, it will return a value of type double to the calling program. So within this function, we have one variable declared called double R. Double R. So this is a variable declared inside the function input radius. It's only known within the function input radius. Its scope is input radius. So this variable is called R. Memory location set assigned to hold a value which is going to have a decimal point or a fractional part, and that memory location is called R. Then we have the statement. This function will display on the screen, enter the radius of the circle. It will read the value entered by the user and store that value in the local memory location or local variable called R, which is of type double. And then this function will return the content of the memory location called R. It will return the content in the memory location called R. It will return to the calling function. So it will return R. So return R is called return statement. Every function, every non-void function in C will have a return statement, and the value that is being returned is what is in the memory that is enclosed in the parentheses after return. Like in this case, the value to be returned is the value entered in the memory location called R, which in this case is the radius of the circle. And that is the end of that function. So the purpose of this function is to prompt the user to enter radius and then return that radius to the calling function. Then we have another non-void function with one parameter that serves as a local variable. So this is our function. This non-void function is called find Perry. It is going to receive, it is receiving one value called double radius. So it is going to receive one parameter called radius. And at the end of its execution, it will return a value of type double to the calling function. So this function is computing the value of radius. In other words, it is computing the perimeter of the circle by multiplying what is stored in the memory location called radius by the content in memory location called the pi by 2 and returning the value as perimeter to the calling a function. My dear students and the rest of the learners, when you find a parameter like this one that has the prefix double, like int radius, and not just radius, it is int radius, it simply means that the value here is the same value that is in the main program. So this is, the value here is being passed by reference. The value for radius is being read by reference, meaning it is accessible from anywhere. So in the main function where it is, if the value there was 20, that is the same value that will be received here. So if this function called find Perry makes any change to radius, the content of memory location called radius, that change will also be made there. So this is called passing by reference. Passing by reference. So this function will just receive the content in the memory location called radius, and because that content is accessible by this function, it's behaving as if it is global, then that content will be accessible from here, and it will be used to compute radius and return back. There will be nothing like storing anything here. There will be no change in the radius by this function. This function is only doing computation of perimeter and returning the value by the call to the caller statement or the calling function. Then here we have another function called double find area. So the function here is called find area. It is receiving value of type double. And then it is returning value of type double. So this is function header. So this function has a local variable. It has a local variable called area. So memory location called area is being declared within the scope of this function. So the content of this memory location called area is only accessible by this function or within this function. And then this function is computing area by multiplying the content of memory location called pi. Remember, pi is a global memory location, is a global variable. I'm calling it global variable because that content can be changed by a program somewhere, because the content is accessible across. And therefore, it's of course a constant. That value is supposed to remain without changing. That memory location that was initialized to 3.142 is supposed to be that way. So we can call it a global constant. So this function is picking the content of pi, which is a global variable, or global constant. Then it is multiplying that content with what it has received as R by itself and assigning the result in the local variable memory location called area. Then it is returning the value or the content stored in the memory location called area. It is returning it as find area. So in the calling statement, find area will be representing the content in the memory location here called area. So find area will return a value, which is of type double to the calling statement. And that's all. So this function is computing the area of the circle. And then we have void function for displaying results with the two formal parameters. So this function here is a void function. It does not return any value, but it is receiving two values. So the function is called results. It is receiving two parameters. One, it will receive area, and it will also receive perimeter. So whatever that was returned by the function called find area as area will be received by this function here. So in other words, from the main function or from the other function or from any other function, the void function called results will receive the value in the memory location called area, and is of type double. And it will also receive the content in the memory location called perimeter. So it will receive perimeter as double and the area as double. So it will receive two perimeters, one called the area and the other one for perimeter. And then it will just display area. It will display the content received as perimeter. Whatever figure it will receive as perimeter, it will display it on the screen. It will display it on the screen. And also the content called area in the following order. So area is equals to, it will pick the content received as area and format it by having two of the last characters representing the decimal places or decimal points or the fractional part. Then comma, perimeter equals to, it will pick what it has received as perimeter and display it on the screen, but it will set the last two characters the decimal fraction, the decimal point to not exceed 2 characters. So, for example, if it receives area as 20.11 and the other one as 11.11, it will display it as area equals to 20.11, perimeter equals to 11.11. And that's all. That will be the purpose of this function, just to display or output the results. Then we have now the main program. This is the one which will coordinate how those other functions will be acted upon. So in this function, we have 2 local variables, or we have 3 local variables declared here. One local variable is radius, the other one is area, the other one is perimeter. So we have the call statement without any actual parameter, this one. So this is a function, or in other words, this is a call statement to avoid the function. That avoid the function was called input name. So this is a call statement to that function. This call statement is not setting any parameters to the function being called input name. So this statement is just requesting or giving the processor an opportunity to perform the tasks under input name function. So what will input name do? So once this function is invoked, the processor will go directly to where the input name function is. So this is it. So that call statement input name without any arguments will invoke the execution of this function here. This function, non-void function, this void function called input name. So what will it do? It will display on your screen or the screen the statement enter your name. It will give the user an opportunity to type his or her name. Then it will display the message welcome and followed by the name entered. And that's all. So once that function input name, once that void function input name, once that name, this function is called by the call statement that we have seen for input name, or by the name input name here, this function will display, or this call statement will provoke or invoke the function called input name to request the user to enter his or her name, get the name, and display the text welcome, so and so. Once that is done, once that function is through with its purpose, it will return back the control to the calling function, which is main. And then the control will move on, or the process will move on to the next function, which is going to call input radius function and assign return value to radius. So in other words, the processor will move on to the next statement. This is the next call statement. This call statement is for a function, and that function is called input radius function. So once this statement is invoked or encountered, this call statement is encountered, the processor will look for the function called input radius and check where it is. My dear students and the rest of the learners, kindly note that this function, wherever it is supposed to return a value, and this value will be stored or will be assigned in the memory location set aside called radius. So the data type for radius is double here, is double. And therefore, the value that will be returned by input radius should be of type double. So in this case, the input radius here will be returning a value. It will be representing a value that is being returned by the function called input radius. So let's go to input radius. So once that statement is executed, or once that statement is encountered, the processor will look for the function called input radius. So here it is, input radius. It is not receiving anything from the calling function, but it is having a local variable declared called R. Then it will request now the user to enter radius. So this statement will follow. Enter the radius of the circle. You enter a value. That value will be stored in the local variable called R, but then it will be sent. If you look carefully, my dear students, the rest of the learners, here, double input radius is returning data of type double. In fact, the value of R, the value of radius here, the content of R is double. And this value, which is of type double, will be returned by this function. And you can see that the return function is returning a value of type double. So that double, so once that is done, once the value has been entered for radius, then the control will be taken back to the main function, which is int, to this point, and the value received, which is radius, or the value received as input radius, will be stored in the memory location called radius. So it will assign the returned value to the memory called radius. Then the next is a calling find Perry function, while passing one argument to it and assigning value returned by the function to the variable parameter. So here is our function. So this function is called find Perry. This find Perry is now going to return the value. Note, this function has brought a value for radius, and that value has been stored in this function, in this memory location here, declared as double radius. So our content, our memory location called radius, already contains a value. So that value is now being picked by this other function here. So the value in the memory location called radius is being now sent as an argument to the function called find Perry. So find Perry will receive a parameter, will receive a value for radius. It will use it to do computation of calculation of perimeter. And the overall result that that function will generate will be assigned to the memory location here called the perimeter, which has been declared here as type double. So we expect that our function called find Perry will be returning data of type double, so that that value, which is of type double, will be able to fit in the memory location declared here called the perimeter. So once this statement is encountered, this call statement, it is calling the function called find Perry. Therefore, this calling statement will send to the function called find Perry one argument, a value in the memory location called radius. So let's go to the find Perry function. So the control will come here the same way I'm doing. It will come to this function. This is the function. So it will look for this function. The function is called find Perry. It is receiving one parameter, which is of type double. So it is receiving the contents of the memory location called radius. So it is receiving. Note, it is receiving the copy of memory location called radius. It is receiving copy of what is in that memory location called radius. It will receive it here. So if under radius we have 20, that 20 will be received here. After this function has completed performing its work, it will send back the result as double. So we have double find Perry. In parentheses, we have double radius. So double radius is the parameter. Is what it is receiving. But this double find Perry simply means that this function will return a value of type double. So This function is simply doing computation. It is multiplying what it receives as radius times the content of that global memory location called pi, the content of that memory location times 2. The value there is being returned by find_Perry. So find_Perry function will return the results of 2 times pi times radius, and that value will be brought back to where the calling statement was. So this is where we were. So that value which has been received, which has been sent back, will be brought here, and it is going to be assigned to the memory location called perimeter. So perimeter will now have a value for perimeter. Then from there, we have this other function called find_area, which is passing one argument, and that function which is being called will return a value. So here we have a function called find_area. This function called find_area is going to be sent a value. It's going to be sent one argument or actual parameter called radius. So this call statement here is calling or invoking the function called find_area, and it is giving it a value, radius. We know from one declaration here that radius is a memory location which is supposed to hold value of type double. And therefore, we expect that find_area is going to return a value, an area which is going to be of type double, and that value will be assigned to the memory location declared here as area. So the value will be stored in memory location called area. So once this statement is encountered, this call statement will invoke the function called find_area. So the control will be taken to that function called find_area. Here it is. So this function is receiving one parameter called double, what is enclosed in parentheses. So that value, that placeholder here, this parameter here, this formal parameter, formal, not actual, this formal parameter is a placeholder. You can see it is being called R. The name does not matter. What matters is that this is the placeholder to hold the value which is being sent, which is being received by 8, and that value is of type double. This function will compute the area and send a value of type double, returning back. So we have a local variable being declared called area. This area is going to hold what has been received times itself times the content of memory location called pi. So the overall result is being stored in the local memory location called area. Then this function called find_area is returning the content of memory location called area. So it is returning the content. Whatever value that has been gotten as the area will be returned by this function. And the value, of course, as you can see, the content of memory location called area, is double. So the content here is double. And the function is double. So this function will now return a value to the calling statement, and this value will be of type double. So once the return statement is executed, the control will be taken out of find_area function and will be taken back to exactly where it was called from here. So the value that has been returned will be assigned into the memory location called area. So find_area, that value which is represented by the name find_area, will now be, the content there will be stored in memory location called area. Then the control will be taken to the next statement. So the next statement is another function. So this function is a void function. It is not returning anything. So, but it is being sent two values. One value is the content in memory location called area. The other value is the memory location called perimeter. So the content of area and the content of perimeter variables will be sent to the function called results. So once this statement is encountered, the control will go and find out where results is, where the function called result is. Here it is. This avoid function for displaying results with the two formal parameters. In other words, it is receiving two values. One, it is receiving a value from code area. So it is receiving a value and keeping it temporarily in a location called area, a parameter called area. And then it is receiving the second one in the same order. And that value is going to be held in the location called, in the parameter called perimeter, is of type double. So this function called results, this void function called results is receiving two values, one for area, the other one for perimeter, in the same order they were in the calling statement. So these parameters must match the arguments. And then what is it doing? It is simply displaying area. So it will display this statement, area equals to, pick what is the memory location called area and format the decimal part to be not more than 2 characters. Then perimeter equals to, pick what's the memory location called perimeter and what is the placeholder in the parameter called perimeter, display it on the screen, but the fractional part not exceeding 2 characters. So that's all. That's what the function will do. Once this statement is executed, once this function has been done, the control will be taken back to the calling function, which is main. And then what is going to happen? So the next statement now, the next statement after the results is to end. So once this statement is encountered, return 0, that will be the end of our function. The control will be taken back to the calling, to the operating system. And that's all. So the input name, input radius, find the peri, find area, and results are a function. Some void, others non-void. The same program can be implemented in Pascal as follows. So we have the program procedure function. Then we are declaring uses because we are going to use some functions to deal with the screen. And then we are declaring the pi as global variables, just as we have seen in the other program. And then we have the procedure called input name. It has no parameters. This function has 2 local variables. One is name, or this local variable. This function has 1 local variable, and this local variable is called name, and it's of type string. Then begin write line, enter your name. So it will display the message, enter your name on the screen. It will give you a opportunity to type your name. So it will read name. Whatever will be typed as name will be stored in the variable called, local variable called name. Then it will display the message, welcome, so and so. So welcome, Julius. If you enter Julius, it will display welcome, Julius. And that will be all with that procedure. Remember, procedures in Pascal is what we call void functions in C. So this function is similar, or this procedure is similar to the void function that I've discussed in C called input name. So the work is the same, and it behaves the same. The only difference is the syntax. Then we have the function. We have the function called input radius. This function is not receiving any parameter. It's not receiving any parameters. It's not receiving any parameters, but it is going to return a value of type real. So function input radius, return value will be of type real. Then we have 2 local variables, or we have 1 local variable called R, which is of type real. So we have begin write line. It will request the user to, it will display the message, enter radius of a circle, then it will read whatever value that the user will enter. and store that value in the local variable called R. And then next, it will pick the value in the memory location called R and assign it to the function input radius. In other words, the value stored in the memory location called R, the local variable called R, that value which is stored in the memory location called R will be returned back to the calling function through the name of the function, through the function name. So this is how we do it in Pascal. Input radius, so assignment operator, what we are returning, the content of memory location that we are returning. So the content of memory location here is the value that has been entered as R, as radius. That value is what will be returned. So in Pascal, we assign the value to the function name. And the function name will go back to the calling function, that is the calling statement, as a value. And that will be all with that function. And then we have this other function here. This function it has one parameter, which will serve as a local variable. So this function is called find Perry. It is receiving one parameter. What is enclosed in parentheses is the parameter. So it is receiving one parameter. This parameter is holding the value of type real, and we are calling it radius. Then this function will return a value which is of type real. So what is this function going to do after receiving a parameter, after receiving a value and storing it in the placeholder called radius? It will then compute the perimeter by multiplying what it receives as radius, multiplied by the content of memory location called pi, multiplied by 2. The result will be assigned to find the Perry. In other words, it will be assigned to the function name. That means the computation or the value gotten will be returned by the function as a value. That will be all with that function. Then the next function is called find area. This function receives one parameter called, or one value, or one parameter. This parameter is being called R. So it is receiving by copying. This function is just receiving R by value. It is receiving by value. So it will receive a value and store it in a memory location called R. That value is of type real. But after the function is through, is over in performing its task, it will return a value which is of type real. So it has one local variable called area. Then it will compute what it has received as R. Whatever is stored in the memory location called R will be multiplied by itself and multiplied by the content of memory location called pi. The value, the result will be assigned in the memory location called area, the local variable called area. Then the content of that memory location called area will be assigned to the function. So it will be returned to the function, back the calling statement or back the calling function or procedure. Then we have a procedure with the two parameters. So this is a procedure. The procedure is called results. It is receiving two values. One, it is the first value, it is storing it in the memory location called area. The other one is being stored in the form of parameter called perimeter. And the content is of type real. So these formal parameters, these temporary holding places are of type real. So what is this procedure doing? It is just displaying what it receives as area and what it receives as perimeter, but formats the fractional part into two characters for both. So it will display the statement area equals, pick what is in the parameter called area, display it on the screen, but reserve two characters for the decimal point, fractional part. Do the same, display perimeter equals to, pick what is the memory location called perimeter, format it into two, format it into 5, maximum of 5 characters, but reserving 2 for the decimal places. And then you end. And then we have these variables here. These are now the normal variables, declaration of variables to be used in the main program. So we have 3 variables: radius, area, and perimeter of type real. These are known in the main function. Then we begin, we clear the screen. Then we invoke the first function, input name. Once this function is invoked, the control will be taken to input name function. Just as I said, it will go to the input name. Input name, in this case, input name is a procedure. So that statement invokes a procedure called input name. So the compiler will come here. This procedure is not receiving anything. It will just do that, set that memory location assigned, prompt the user to enter name, read the name, display, welcome, so and so. Once end is executed, the control will be taken back to the main program, to where the call statement was, back to where we were. So the control will be brought here next, because that is a function, it will be moved next line. So next line is this other statement here. This is a call statement to a function. Anytime you see this assignment operator, a function being assigned to a certain value, that tells you, or a certain memory location, that tells you that's a function. So here we have a function. This function is called input radius. We are not sending anything to it, but it will bring back to this program a value, and that value will be stored in the memory location called radius. So once this statement is encountered, the compiler or the control will be taken to the function called input radius, wherever it is. So it will look for it, function called input radius. Input radius, here it is. So this is the function. So the control will be brought here and find out that this function is supposed to return a value of type real. So it will do that, execute that statement, and then it will display the message, enter radius of a circle. It will allow the user to enter the value. It will read the value. That value will be returned back to the calling function. So the value in memory location called R will be picked and be returned back through this return statement, which represents the name of the function. So the function will end, and the control will be taken back to the calling function or the calling program, and our calling program is the main program. So whatever that has been entered as radius will be whatever has been returned back as value for radius. It will be assigned to this memory location called radius that we have declared locally under variables here as type real. Then from there, the control will move to the next line. It will invoke this other function here. The function here is called find Perry. So the value that is stored in the memory location called radius will be picked, be sent to the function called find Perry. Find Perry will compute the perimeter and return the value back, just as we have seen for input radius. It will return the value. But I want you to see, my dear student, how this works, because this one has a parameter, an argument, but input radius didn't have a parameter. So once this statement is invoked, the compiler or the processor will pick the content of memory location called radius, send it to the function called find Perry as a parameter. So let's see find Perry. So here is find Perry. So here is find Perry. So this is the function, find Perry. It's a function. It is receiving one parameter, one value, which is of type real. And that value is being stored locally here by a parameter called radius. So the value which has been sent from the main program, it will be brought here, be received under radius, as real. Then the program will compute perimeter, send the value gotten back through the name of the function as real to the caller, to the main function or to the main program. And our main program will now be at this point. So the value received or the value returned by find peri function will be assigned in the memory location called perimeter. So then it will move on to this other call statement. This is similar to the find peri, but this one now is for computing area. So the content of memory location called radius, the value in memory location called radius will be picked, be sent to the function called find area. Find area will receive this parameter, this argument as a parameter, the value as a parameter. Use it to calculate area, then the function will return the value, the results, and assign those results to the memory location called area. Next, the control will be taken to the next call statement. Here, this call statement is for a procedure. This procedure is being sent to, or two parameters are being sent to it, two formal or two actual parameters or arguments are being sent to it. One is being sent as area, the second one is perimeter. So the receiving procedure will have two parameters. One parameter for area, the other parameter for perimeter. And here it is. This is the procedure called results. So it is receiving two parameters. One parameter is area, the other parameter is perimeter, and they are of type real. Then it will display the area and the perimeter formatted as I have already explained. And then once end is encountered, the control will be taken back to the main program and it will come back to where it was calling. Because there's nothing which has been returned, the program will end. That will be the end of that program. So the following is a C program implementing prototypes. So we saw prototypes in my previous presentations, and we can do it as follows. So this program is implementing the subprograms that we have already discussed and the parameters that I've already discussed about. But the difference now is that this program is implementing what we call prototypes. So we have hash include std.h. We are declaring our global variable just as the others. And then here we have what we call function prototypes. We use these ones when we don't want to define the full function before the main function. So function prototype. So we have the first prototype is a function that is void. So this void function is called input name. Prototype is just informing the compiler or the processor about the existence of these functions. The details about what they do are done after the main program. That's the only difference. So we don't define the function here. We only list them. We only declare them. So the second one is a function called input radius. This is an void function and is supposed to return a value of type double. Then the next is a declaration of another function. This function is called find peri. It is going to receive one parameter of type double, and it is going to return a value of type double. Then we have another function which is called find area. It will receive one parameter as double of type double, and it will return a value of type double. And then we have this void function called results. It is not going to return anything, but it is going to receive two parameters. One of type double, it will call the area, the other one of type double called perimeter. So my dear students and the rest of the learners, this is simply called variable declaration. You are declaring them, just informing the compiler about or the process about the existence of these functions. But what these functions do will be done later after the main function. So we have the main function. In the previous example, you have seen that we were defining the activities and the operations within the definition before the main. But here, we have only listed the functions we are going to have. So we call these function prototypes. Their definitions are after the main program. So we come to the main program. We have the local variables declared, just as we said. We have the first function being invoked. So this time, the compiler is aware about the existence of this function. This function is void. Void is what we are calling procedure in Pascal. So once this statement is executed, the control will come out of the main function and go and find out where that function is. Here is our void function. So the control will be brought here. It will do that. It will do that. It will do that. It will do that. Once this execution is over, the control will be taken back to the main function, to where the call statement was called. And then because this was a void function, the control will be taken to the next line. So this next statement will be invoked. This statement tells the control, the compiler or the processor, to go to the function called input radius. Already it is aware from the declaration that there's a function called input radius. It is not receiving any parameters, but it is going to send or return a value. So that value which will be returned will be stored in the memory location called radius. So the control will be taken back out of the main function all the way to where that function is. So the function is here, input radius. It is not receiving any parameters, but it is going to return a value of type double. So it will execute these statements and return that value to the calling statement of the caller. So it will be brought here. The value received as input radius will be stored in the memory location called radius. Then control will be taken to the next line. This next line is for another function called find Perry. It is going to send a value stored in the memory location called radius. So the call statement will send a value from the memory location called radius to the function called find Perry. The results of that function will be assigned to the function called perimeter, or not function but memory location called perimeter. So after this statement is encountered, it is invoked, the control B will move. It will pick the content memory location called radius. Go with it to the function there for perimeter, the function called find Perry. So that value which was being carried will be dropped here in this parameter called radius of type double. Then the function will compute that and return a value of type double. So that value will be carried all the way to the calling statement here. So the value received will be assigned into the memory location called perimeter. Once that is done, the control will be taken to the next line. So this is another function. This function is called find area. The value of memory location called radius will be sent to this function called find area, and the resource of that function will be assigned here. So what will happen is the control will come out carrying the content of memory location called radius. It will go and find out where find area function is. Here it is. So that value, which was carried as radius, will be dropped in this parameter called R. And the function will do that. It will compute area and return the value of area back to the calling function, the calling main function. So the control will be brought back all the way to the caller here. And then the value returned by find area will be assigned memory location called area. Next is a call statement for a void function called results. So the control statement or the controller or the processor will pick the content of memory location decode area and the content of memory location decode perimeter. Carry the two in that order. Go out and find out where the void function called results is. Here it is. It will come and drop the content, the value being carried, the first value, it will be dropped in the first parameter area. The second value being carried will be dropped in the second parameter called perimeter. And then it will do the following. It will print out that statement, display the content of memory location decode area and that one of perimeter, formatting that order. So it will display the statement area equals whatever it is with 2 decimal points or places, and perimeter equals whatever is in the perimeter location, memory location, formatted in 2 characters or 2 decimal places, and it will end. Then the control will be taken back again all the way to the calling function. And the calling function is main. So it will come here. Nothing to be returned. So it will move on to the next line. It will encounter or execute return 0, meaning return control back to the operating system, and the program will end. And with that, my dear students and the rest of the learners, that is how the functions, void functions, non-void functions, procedures and functions, as well as prototypes, parameter passing, and the parameters, local and global variables are implemented in programming. And with that, we have come to the end of section 3 in this presentation on implementation of subprograms. Continue to section 4 of 4 in this topic so that you learn about recursion. Congratulations for learning section 3 of 4 of the topic subprograms. You can also access section 1, 2, and 3, section 1, 2, and 4 of this topic, other topics in the computer structured programming, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emeliswap@gmail.com. Thank you very much for listening to me. Let's meet in part 21 of this series to learn the last part or the last section in this series. God bless.